Hi, everyone. My name is Aaron Lee. I'm a physics faculty member here at St. Mary's College. And I thought I would talk a little bit about some of the research opportunities that are available to you here at St. Mary's. The School of Science runs a summer research program every summer, which is 10 weeks. You get paid, where you work very closely with a faculty member on something related to their research program, or in some fields, you could even potentially propose your own research program or question if there's something of interest you want to think about. This is something that a few of us in the physics department have participated in, and we plan to continue doing so in the years to come. Particularly, I do my PhD is in theoretical astrophysics. I'm a computational physicist by training. So I study astronomy and astrophysics through the use of giant numerical simulations. Using some of the largest supercomputers in the world, I take light year sized clouds of gas, let gravity do its thing, and analyze how big clouds of gas out in space collapse from their own gravity and eventually form stars. So how stars form, how stars evolve, those are big questions that I like to think about. And if you were to participate with me in this sort of research program, what these simulations provide is literally terabytes of data that need to be analyzed. And within those terabytes of data are a huge variety of different stories that can be told about particular stars, about kind of what's going on globally. And so there's an incredible wealth of research questions that can be answered using the simulation data. So you would get the opportunity to work with me using this data and trying to make sense of it in a way where you can take literal, XYZ coordinates, 3 dimensions of velocities, masses, but there are billions of these. And you have to somehow, through the use of computer programming, turn that into something that tells a story rooted in physics. The nice thing also about this work is that since it is purely computational, it really just requires an internet connection. So even if you want to participate in research but didn't necessarily want to stay on campus over the summer, that's also a possibility. Remote working opportunities are possible. And we did that last summer, particularly. Another thing I'm really interested in is using computers and simulations in education, particularly in the introductory astronomy sequence. How these students effectively engage with the wealth of scientific data and do actual science in these introductory science classes is a big question for those of us who teach introductory astronomy. When I say introductory astronomy, what I mean usually is like what we call Physics 90. It's one of the core requirements. It's usually kind of a gen ed, broader education type course, introduction to astronomy for non-majors. Very, very popular at many universities across the United States, is typically used to satisfy the sort of broader education science requirement. And therefore, as a result, is likely going to be the last formal science course a lot of those students take. It there is for my responsibility as the instructor to make sure they leave those sorts of courses with the ability to define science, with the ability to understand how we answer scientific questions, and to also appreciate that they themselves can do science as well. Science is not restricted only to a privileged few. So I do this by using computer simulations, web design applets, where I allow students the opportunity to interact with all of this great scientific data that professional astronomers have collected. So a student last summer worked with me on some of this, where we developed computational labs that are going to be done in Physics 90 this semester. It was in a collaboration with some colleagues over at Harvard University, which we'll be continuing in the years to come. We're also really interested in developing more we're also interested in the web design approach with this, where we can start to incorporate these simulations and interface them with something that you can do on a web browser. So those of you who might have any interest in kind of programming, web design, even if you don't necessarily, love astronomy, like there are opportunities here where you can use astronomy to kind of develop the skills that you find really fascinating and interesting. Ultimately, both of these sorts of research programs are getting to thinking about how we make sense of the world around us and how our results can be communicated effectively in the 21st century. particularly with the education avenue, students who are interested in going into primary and secondary education may also benefit. Because in developing these tools, we think a lot about what the education literature says about how students effectively learn science across all ages. So I hope that gives you a sense of kind of what sorts of opportunities and what the benefit is of doing something like physics here at St. Mary's. And I hope you'll consider not only doing physics, but participating in research programs that are available to you. And again, please reach out directly to any of us here on the faculty if you have any questions about any of this. All right, thanks.